Man, it's really hot, but I'm gonna get some coffee anyways. Woo! Man, gotta bring this fan out. Well, I better just fan myself at 1 fan per second so I don't get too worked up. Rachel's drinking water, but she's really hot too. So Rachel starts fanning herself at 5 fans per second. However, since I started fanning myself 2 minutes before Rachel, I wonder how many seconds it's going to take for her to catch up with my number of times that I fanned myself. So to make an equation, I fanned myself 1 fan per second plus the additional 120 seconds, and Rachel had a consistent speed of 5 fans per second, where T is going to be the amount of seconds we were fanning. So in order to find the amount of seconds it takes to reach the same amount of fans, we set both of our equations equal to each other to solve for what number of seconds will create an equal amount of fans. As a result of this, we ended up getting 30 seconds for T, which means at time of 30 seconds, the number of fans that we have both fanned will be equal.
Man, it has been so hot today. I can't stand this heat. I could really use some water right now or something. Oh my gosh. Oh my, perfect. Okay, Mom said not to ever get worried about brain freezes, so I should probably do a sip every 3 seconds. Oh, screw it, I'm hot. Looking at this graph, at the beginning you can see that I was taking 1 sip every 3 seconds for 12 seconds. That's a total of 4 sips. Then when I was drinking the water at a faster rate, I was drinking 1 sip per second for 12 seconds. That's a total of 12 sips. So in a total of 24 seconds, I drank 16 sips of water. So looking at this graph right here, you can see the point at which I changed and started drinking at a faster rate. Okay, so here I have a glass, and as you can see, the bottom is slightly smaller than the top up here. So when we fill this with water, it's going to be quicker filling up at the bottom and then take more time as it gets towards the top. But if you compare it to this Coke bottle right here, at the bottom, again, it is going to be a little slower, then it gets skinnier, so it'll be quicker, and this will be pretty consistent until we get to this top part where it'll fill very quickly. So this graph is going to be more of a wave going up and down, as opposed to a graph for this glass, where the graph is going to be consistently going like this. So looking at these 2 graphs right here, you can clearly see the differences in the rate at which the water filled up in the glass. And the clear glass, it was quicker at the beginning, and then it was slowly consistent filling to the top, and then once it overfilled, it was consistent. And the Coke bottle, it was quicker in the beginning, and then pretty consistent going towards the top, and then at the top it quickly filled up, and then evened out as it overfilled.
Alright, I am ready to pay my bill.
Here it is.
Oh, my bill's 40 euros. Oh my gosh. I am so broke. I don't have any more euros. Can I please borrow 40 euros?
Again?
Yes. How much do I already owe you?
23 euros.
Okay. Can I borrow 40 more euros? For a total of how many euros would I owe you then?
Let's think about this.
So if I already owe you 23 euros and now I owe you another 40 euros.
How are you thinking about that?
I'm thinking about this as a negative 23 adding another negative 40. I'm going to owe you $63 in debt. So I'm at a negative 63 euros. Not dollars.
Okay, well, I will
give you the 40 euros, but you have to pay me back.
Thank you so much.
So I'm here at my local supermarket. I'm throwing a fiesta for a large number of people, and I want to make Tinto de Verano for everyone. But I have this bottle of wine, which is 750 milliliters, and this little bottle of 7-Up, which is 237. So in order to get a half and half ratio and be able to use everything that I buy, I need to find the least common multiple between these two bottles. So to do that, what I did was I factored out each number, and I found that I need 59,250 is the lowest common multiple. So I need 250 bottles of this little thing of 7-Up and 79 bottles of wine in order to create my Tinto de Verano for a fiesta.
Yay!
This image shows the prime factorization of 750 and 237 and how I got the least common multiple from these prime factorizations. This video shows me walking down the stairs in my apartment building, getting to the bottom, realizing that I forgot something, turning around and starting to walk back up the stairs. About 2/3 of the way back up the stairs, I stopped for 2 seconds and then continued walking. This distance time graph shows my initial walk down the stairs, where I paused to turn around, walking back up the stairs, stopping for a break, and finally finishing the walk up the stairs. In this position time graph, you can see the increase in position distance from my house as I'm walking down the stairs, the stop at the bottom, and then the decrease in position distance from my house as I'm walking back up the stairs.